Welcome to the session Specification for Fine Aggregate used in concrete. Myself, Mr. Chetanji Konapure, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. So, these are the learning outcomes. At the end of this session, student will be able to describe the specification for fine aggregate which is used in the concrete, and the student will be able to decide the acceptance of material as fine aggregate. So, this presentation actually deals with the material which is used as a fine aggregate in the concrete, and basically the material used is river sand, and the other sources are also used. But what are the specifications for the fine aggregate to be accepted to use in the concrete? Now, why this discussion starts? River sand, which is one of the content used in the production of conventional concrete, and it has become highly expensive and also scarce. Basic problem is the scarcity of the river sand, and in the backdrop of such a bleak atmosphere, there is a large demand for alternative materials from industrial waste. This is second issue. Now, in nearby local area, river sand is wisely used as a fine aggregate in production of cement, mortar, and the concrete. So, only one material is till date used as a fine aggregate for the mortar and the concrete, that is river sand, because there are two rivers. One is the Bhima river, which is a major river, and second is the Sina river. Now, what are the issues? Let us see. Sand becoming expensive due to the first problem is scarcity and excessive cost of transportation from natural resources. Now, Bhima river is having a maximum distance of 40 km from the city, Solapur city, and nearby the area, and different locations are there in the Bhima river to get the sand, but scarcity is the main problem, and second is excessive cost of transportation. Now, major problem of this river sand extraction is the large scale depletion of these sources creates environmental problems. That is the basic issue for the river sand. Now, if there is the scarcity problem, there is the excessive cost problem, there is a large scale depletion of an environmental problem, then we have to think of some substitute or replacement product for concrete industry needs to be found. Now, let us see what are the alternative material for the natural sand. Then we can see that what are the specification and are they really satisfying the specification or not. That has to be checked. Now, the first is this quarry rock dust. Now, what is quarry rock dust? It is a residue or other waste material after the extraction and processing of rocks to form fine particles less than 4.75 mm. Okay, so this is quarry rock dust. So, the basic thing is that the extraction and processing of the rocks to form fine particles less than 4.75, this is waste material from quarries, rock quarries. Second is marble powder and granules, and it is a byproduct of marble production process and also create large scale environmental pollution. So, wherever the marble industry is there and marble cutting, marble slits are made. So, in those industries, the marble production process and the byproduct of the marble production process is the marble powder, which is in the wet form. Third is granulated blast furnace slag, which is a waste product of steel industry. Especially all the metal industries are producing this blast furnace slag, but in the case of steel industry, that GBS, that blast furnace slag is used as a fine aggregate. Now, the last is crushed sand. So, crushed rock particles below 4.75, this is also one of the material used. Now, let us see, this is what are the few textures about these materials. Quarry rock dust, this is the quarry rock dust, you can see here. Now, this is marble powder, you can see the powder and its finish. Now, this is granulated blast furnace slag. This is crushed sand. So, all the four alternative materials, their textures and photographs we have seen. Now, next is what are the standards for the material to use as a fine aggregate. Any material can be used, but which standard we should study to consider that material as a fine aggregate. And the Indian standard for sand or fine aggregate is IS 383/2016, which is a specification for coarse and fine aggregates to be used into the concrete. IS 238 suit 1963 parts 1 to 8. Next is concrete. For concrete, this is to IS 10262 2019 and IS 456 2000. These are the 4 codes which are used for concrete and sand. Now fine aggregate. Now what is meant by fine aggregate? The aggregate passing through 4.75 mm defined as fine aggregate. Depending upon the particle size, fine aggregates are described as fine and medium or coarse sands. And on the basis of the particle size distribution, the fine aggregates are classed into 4 zones. This is the specification given in IS 383. Now these grading zones being progressively finer from grading zone 1 to 4, IS 383 2016, so that we are going to see. Now what are the terminologies? Let us see. Fine aggregate, the different terminologies are given. This is a natural sand. So fine aggregate resulting from the natural disintegration of rock and which has been deposited by streams and glaciers agencies. So this is uncrushed sand. Now next is crushed sand. Crushed stone sand, fine aggregate produced by crushing hard stone. Crushed gravel sand, mixed sand, manufactured fine aggregate. These are the 4-5 definitions which are used in the concrete. Now fine aggregate, the grading of the fine aggregate when determined as described in 2386 part 1 shall be within the limits given into table 9 and shall be described as fine aggregate grading zones 1 to 4, where the grading falls outside the limits of any particle grading zone of the sieves other than 600 micron IS. So this is the definition given for the fine aggregate. So we should carry out the fine sieve analysis or particle size distribution, and the percentage passing of the fine aggregate shall be matched with one of the grading zone, and we have to check that. Now this is next the point or grading zones which is the first criteria or first specification for the fine aggregate. So these are the sieve sizes 10 mm to 150 micron, and these are the 4 grading zones which we are giving the percentage passing for fine aggregate. Zone 1, these are the values, zone 2, 3 and 4. If you observe this zone 1 and 2, percentage passing for all these sieve sizes, grading zone 1 percentage passing a little coarser and grading zone 4 the percentage passing is finer. Most important note in this table of IS 383 is it is recommended that fine aggregates conforming to grading zone 4 should not be used in reinforced concrete unless tests have been made to ascertain the suitability of proposed mixed proportions. So note 4 is very important. If your sand belongs to or fine aggregate belongs to zone 4, it shall not be used in the RCC. This is the note. Now let us see the explanatory table of this grading of fine aggregate as per thread. Zone 1, 2, 3, 4, these values are given. If you see the coarser material, as you go towards zone 1, that is more coarser material, and zone 1 is having this 90 to 100 and all these values. As you go towards zone 4, 3 to 4, the material is finer material. Now, most important thing in this for 4.75, 2.36, 1.18, all these 3 sizes, if you consider all those 4 zones, zone 1, 2, 3, 4, 90 to 100 and 95 to 100. So the common values may be there for all these 4 zones. For 2.36 size, 60 to 95, 95 to 100 is the first and last value of zones, and in between the combined values are also there. And 1.18, 30 to 70, 55 to 90, 75 to 100, 90 to 100. All sizes are having common values in these 4 zones. Most important value or most important size is 600 microns, in which the values are differentiated from each other. So zone 1 15 to 34, zone 2 35 to 59, zone 3 60 to 79 and zone 4 80 to 100. So the sand samples or fine aggregate samples are differentiated basically by this 600 micron, which is also called as pure sand. Now the coarser materials are towards zone 1, that is considered, and finer materials go towards zone 4. Now these zones percentage passings are considered in this graph, and grading curve limits for zone 1 to 4 are given. Zone 1, 2, 3, 4. Percentage passings are on y-axis and the sizes are on x-axis, and zone 4, this is the lower and upper limit of zone 1, lower and upper limit of zone 2, lower and upper limit of zone 3, lower and upper limit of zone 4. Okay, now in this case, the zone 1 is coarser and zone 4 is finer. So, according to these graphs also we can study, we can judge the percentage passing of the fine aggregate. Now, this is the limits of deleterious materials according to IS 383 2006, in which the different deleterious substances are given, and coal, lignite, clay, material finer than 75 micron, all these things are given, especially for the crushed and mixed sand. These values are specified here, which is encircled. So, for coal and lignite it is 1%, for clay lumps 1%, material finer than 15%, and for uncrushed, crushed, manufactured sand, fine aggregates, these values are given. For crushed sand, if you see, it is 15%, and even notes are also given to how the fine aggregate shall be checked. So, these are the references for this session. Thank you.